All right, let's take a look at this problem. It says that we have a rod that's pivoting about its center, right there. We have a 5 Newton force applied 4 meters away at an angle of 30 degrees, and we have a second force of 5 newtons applied 2 meters away as shown. What's the magnitude of the total torque of the pivot? So we want to figure out what is our total torque on this problem. Well, we know that torque, by definition, is given by a distance that a force is away, and we multiply the distance vector crossing into the force vector. The way that we remember this one, normally solve problems, is df sine of theta, where theta is the angle between the d and the f vector. So I have to ask myself, what are my magnitude of my I have my two forces. They can give me two torques, so I have to calculate what the values are. So this guy up top, this one on the right, is 5 newtons at a distance of 4 meters away. And if I look, this distance, this is going to be F1 D1, and I know that my angle is measured from the displacement vector into the force vector. So that means that this angle is 30 degrees. So sine of 30 degrees, or theta 1. Well, if I work this out, my torque 1 is equal to 20, and the sine of 30 degrees is 1/2, so I get this to be 10 Newton meters. And I want to know what direction it points. So if it goes d into f, I can use my right-hand rule to help me out. I go d into f, and I see that it points out of the page. So I'm going to say this is in the positive z direction. X, y, and z comes out of the page at us. Positive x, positive y, positive z. So this will tell me that when I add my vector, my torque vector, I make sure that it's in the positive z direction. All right, let's look at the other torque. This other torque over here is F2 times D2 times the sine of theta 2. D2 points in this direction, points from the axis of rotation to where the force is attached. Our force has a magnitude of 5 newtons, and theta 2 points from the displacement vector direction, rotating into the force vector direction. So theta 2 is in this direction. So when I work this out, tau 2 is equal to 2 meters times 5 newtons times the sine of 30 degrees again. So this is equal to 5 Newton meters. 2 times 5 is 10, times 1/2 gives me 5. So tau 2 is 5 Newton meters, and I want to add the direction in on this. So I take my hand, I go displacement into force, so 1 into 2, so force crossed into, distance, displacement crossed into force gives me my torque. Again, it's pointing at us, which is in the positive z direction. So when I actually do my total torque with vector quantities, because I have to, it is a vector, so when I add them, I have to make sure I take that into account. It's 10 Newton meters in the z direction, the z hat direction, and it adds to 5 Newton meters, again, in the positive z hat direction. So my total magnitude is 15 Newton meters, and I know it's in the z hat direction. So my correct answer is 15 Newton meters. And it tells me, actually, one step further, it tells me that my total torque points out of the page.